Hello, folks. Myself, Aru. I'm working as a SRE engineer in Freshworks. With me, my colleague Keerthi. He is also working as a SRE engineer. So now we are going to talk about how our app aware about our infra, and similarly, our infra is aware about our app. This is something similar. Like day to day, we see we in a family we have a wife and husband. If they both understand each other, they will run a healthy family life. Similarly here, if app awares about your infra, then your application will be much more scalable, and with that you can serve your customers seamlessly, which will generate you a much more revenue, right? So same way in real life, if you see, if husband and wife have a great understanding, then both husband and wife work peacefully without any worries, and they can generate more revenue to the family. So, here in this one, we will give you some examples like what we have done in our application. So before going into deep on that, I would like to spend few minutes on explaining how our infra is. So, and how our regular work to the app and how it will, how the works happen in the background and everything, right? So, our application is multi-tenant application, and for distributing the load, we have a sharding in the database. So, sometimes we will have a single tenant present in the shard, and sometimes we have more tenants present in the same shard. So, and there will be regular, since it is a SaaS based application, there will be regular inflow of traffic, and for certain actions we do have a background job processing as well, and these are happening in a like every time this will be like in a day-to-day life. And apart from this one, we will have a certain maintenance activity as well. So in our SaaS application, it is mainly a ticketing kind of tool. So we like whenever our customers are creating a ticket, we can't keep it for a lifelong, right? So we have to archive the ticket. And similarly, we follow GDPR compliance and everything. So whenever any customer is leaving us, we have to wipe their data. And same way, customer can choose like don't track this data for this particular customer, or like that they can have configuration as well. So for this one, actually we have to do certain maintenance activity along with the regular day-to-day activities. For this, we choose like very minimal traffic times, but sometimes based on our nature of our application and customer use cases, even during the minimal traffic time, there can be a sudden burst in the load. So when we are doing a maintenance activity, there will be a heavy load to our database, since we have to do lot of data wipe and everything, right? So when we are doing that particular process, if there is a sudden burst in the regular traffic which we should not impact, in that case our DB will become a bottleneck, right? So since our DB is becoming bottleneck, this will cascade the impact to our application, which in turn show the poor performance for our customer. So to avoid this one, what we have is like we have one common man between our application and infra. This is something similar to some common uncle or auntie in our family, right? Who understands both wife and husband, and they will help to run our family much more smoother. So this ops manager is my uncle or auntie. You can assume like that. So what this ops manager knows is whenever there is a load or DB is not able to handle, it is about to breach its threshold, and after a certain point the customers will notice that there is something problem in the application that I am accessing. So this will detect that and send a notification, from the DB, it will send a notification to the ops manager, and ops manager note that down, and it will store in a common place which can be accessed by our application. So while running the maintenance activity, we do run in a batch by batch processing. Since we have to do a lot of maintenance activity, we can't run all at a time, and we do run a batch by batch. And on each batch, we will check, is there any load detected by my ops manager for the shard that I am running. So if there is a detection, my ops manager would have put some data in somewhere which my app will access and came to know that, okay, I am troubling my husband, so I will slow down. So it will slow down. It will reduce the concurrency of the maintenance activity, because this maintenance activity can happen later also. It is not like it has to happen right now. It can happen later also. So by reducing this concurrency, I will give a room for my regular traffic. So my customers who is accessing my application won't see any latency and they seamlessly access and revenue will flow in, right? So this is one thing. This way here we have shown like how we are solving for DB bottleneck, right? So same way you can do for multiple other bottlenecks as well, right? Maybe one example, most of you might have used LRU cache in your application, right? But LRU cache, it will do the cleanup when it is about to breach the memory. So let's say we have a 10 GB of cache size. After 9 GB only it will decide, okay, I'm going to breach, I'll do a cleanup so that I can create room for my application to fill in further. So if you do that in a heavy loaded system and regular traffic flowing time, if you do that, it will definitely have a slight impact. It may not be much impact, but there can be a slight impact. So to avoid that also, we are using the similar way. Like we will have a there will be a critical threshold and a warning threshold. Our ops manager will trigger another application which does another kind of maintenance activity, and it will decide when to do. And that warning threshold will be like maybe 10% lesser than our critical threshold. So while doing that, we will ensure that all the expired keys are the keys that are about to expire in 1 or 2 days, or that are not least recently accessed, means that also we will clear before even it is reaching the critical threshold. So we will create room for our application or our cache server to hold much more data and perform better. So, and when this is with respect to the data store and something, when it is coming to the infra part, like mainly like what data store and everything also an infra only, when I mention like it is a compute layer, right? So we are hosted in the Kubernetes. Mostly everyone must be aware about Kubernetes in the recent days. So in Kubernetes we have multiple components, right? So mainly we have a master node group and worker node group. So this worker node group is the node group where our entire application will be running, right? So we have, so since our application is a little huge application, so we have a segregation between our workloads. Maybe for in foreground processing application should not be hosted in the same compute where background processing is happening. This is to ensure background processing that is happening in a higher rate is not impacting our foreground application. Okay. So similarly, we have a very critical proxy applications and all. That needs to be up and running to route your traffic to our application. If that is down, the entire system is down, even though you have a app and BG and everything is running. So that is a very critical application which will be hosted in a different node group. Similarly, we have multiple node groups in our application. Let's take an example here. There are 3 node groups present in our application. Okay. Out of these 3, we have 2 node groups which is performing better and 1 node group which has some problem. Let's take these node groups are our application node groups. Okay. So in these 3 node groups, out of 3, there is 1 node group which is performing poor, which has a certain workload which is right now processing a live traffic. So because of this can be due to a compute problem or can be due to heavy load to the system or anything it can be, right? So, but it will create impact to our application. Let's say we are serving 1 million RPM at this time, right? Out of these 2 parts might be contributing around 10% of traffic. Those 10% of traffic will get impacted, which will further have a cascading effect and the impact will be growing. So to avoid that, again our ops manager will detect this one and that will evict this node, right? First so in Kubernetes we can directly evict that node. So first we will taint the node so that our autoscaler will know that no further parts will be scheduled into that node. and then we will drain the node. That has to happen seamlessly. So it will drain the parts that are already running in that one, and it will evict the node. So the new node will come, which will perform better, and we will solve the issues here.
So the Sidekick is basically just a background job framework with uses Redis. So the queues are present in Redis, and so Sidekick. The Sidekick is basically a background job framework which is backed by Redis. So all the queues are maintained there, and most of you know aware of this, I think. So let's have some scenario. So there are millions of tickets are inflowing to our tool. Okay. So there are millions of tickets are inflowing to our tool. So there may be many background jobs. So one example is such SLA jobs. Let's take if the ticket's SLA is 5 minutes, then after 5 minutes we need to send some trigger notification to the respective persons who respective owners of the ticket. So it's something like that, and let's consider that will happen in the background job framework. So there will be millions of jobs getting processed each time. Let's consider if the Redis is down. So then if that is around, then all the customers will come immediately. So some part of your app is not working, so something like that. So to avoid this when Redis is down, so app needs to aware of that. So Redis is already down. So it needs to resume the live traffic also, and it should not we should not have a room to occur any downtimes. So that's something called this is SQS framework, which is Sorican. So it is same kind of queuing background framework. Instead of Redis, Sorican will use SQS as a queuing job. So this is one kind of example how your app and infra needs to be aware. So it may be some other framework also, Spring Boot or some other queuing systems also. If you have a fallback thing, then app is aware of that infra is down, and if you have fallback, then we can avoid such big downtimes and everything. So another thing is, as Aru told, we already hosted in a Kubernetes environment. So our foreground jobs, we have a auto scaling HPA. So I will set some brief about HPA. So horizontal pod auto scaler. So it works on some metrics like we can able to configure the metrics and custom metrics and like. So I will take a simple example here. When the RPM increases, we need to auto scale the pods. So we are serving millions of billions of traffics every day. So let's take there is a sudden spike of traffic from our users. So then the autoscaler we need to scale the pods. There are two issues here during the auto scaling. So one is if after the autoscaler is getting triggered, one issue is it needs to trigger cluster autoscaler needs to boot up that much nodes. So let's take we have 100 foreground pods. It's getting triggered by the horizontal pod autoscaler. Then the cluster autoscaler needs to give a room for accommodate all those 100 pods. So it needs to boot a node. After booting a node, all those pods, it has a Docker image, right? So it needs to pull Docker image for those applications inside that each node. So there are two delays happening here. So I will go one by one. First, in delaying in pulling image. So let's consider one pod is getting booted. In our application, we have 5 containers. One is a main container, which is a foreground app, and remaining 4 containers are our sidecar apps, which do some other istio and some kind of operations. And the foreground app, which has around 2.5 to 3 GB of image size, and other sidecar containers has 200 MB to 400 MB sizes. So all clubbed together, it will, for one pod, we will have some 5 GB of images. For each pod booting, it needs to be pulled that 5 GB of images into that node, local Kubernetes node. If the next pod comes up, it will reuse of that thing. So, but the delay it will cause is, so for pulling the images, it quite take 2 to 3 minutes definitely. So let's take a sudden spike from 1 million RPM to 10 million RPM. Then your autoscaler triggered, but the pods are not got booted. Then it will end up to a request queuing and 5xx kind of things. So to avoid these things, what we suggest is, so a daemon set, so what the daemon set is do is, so it will be booted in all the nodes when the node is getting booted. So that the purpose of the daemon set is it hours about our app images. So what it does is it will pull all those app images in the node. So when the node is getting booted up, all the images will be present in the daemon set itself. So when the app pods are getting booted up, it says like the image is already there, so I will boot up quickly. So that's the one part we can decrease the time. So and the second thing is the node availability. So let's consider to accommodate that 100 pods, right? So the autoscaler gives like you need to boot 100 pods. So to boot 100 pods, let's consider the Kubernetes triggering some 10 node booting a 10 node EC2s, and let's consider if that is booting 10 nodes, then there might be some delay, like it will first needs to be reached a cloud provider, and the cloud provider needs to give the node room for that one, and the nodes, all the daemon sets needs to be booted first, then only the app pod will get scheduled in that node. So it will roughly take around 2 to 3 minutes. So same problem will arise here. So like the request queuing and 5xx kind of things. So to avoid these things, what we are suggesting is, we are doing some kind of busy box deployments. So what does is, it's a simple part. It will sit on every node. It will occupy whole space of that node, but it has low priority. So your app pods will have high priority. So whenever your app pods are getting scaled up, so these low priority nodes are evicted, and the Kubernetes will schedule those high priority pods into that these empty nodes actually. So which means that the nodes are already scaled with these busy box deployments. So whenever it's needed. So you can also have some traffic pattern, and you can configure some scaling for this busy box nodes if needed. So that's the thing.
Yeah. In addition to what Keerthi has told, so when I mentioned we have a multiple node groups, right? So these node groups are configured across multiple availability zones. So whenever our cluster autoscaler is scaling, it can scale across multiple availability zones. So this busybox deployment also we have configured to run one per availability zone. So that across all availability zone, we have one additional node available always to scale the pods or schedule the pods efficiently. This call you have to take cautiously, and this is like, anyways, when you are running an additional node extra to the nodes that are needed for your traffic, then there will be an increase in cost. So there should be a trade-off between cost and performance here. So based on that, maybe you can schedule like, or have at least one node alone additionally per node group, or across all node groups you can have one node. That can be a decision that you can take based on the need or which is higher priority for you, because here it is in our case it is mainly our customers' experience is much more priority compared to the cost, because with the better experience we can generate much more revenue. So with by taking that call, we have configured this busybox to run in multiple AC, so that across each node group we will have one node available always. So whenever there is a burst in traffic also, we will have a node to be available. Yeah. We have done multiple other things as well, like I mentioned the cache and other stuffs. We have something did for the Redis overload as well, which also we have taken the similar approach like Keerthi mentioned, backing up with the SQS and other stuffs. So with this ops manager and with having the awareness or creating the awareness between the app and infra, you can expand this to multiple things and scale your application much more as well. Yeah, with that, this is what we have. I am ready to get the questions from you guys. So busybox will be running always. So as I mentioned, it will be running always like another part, and it will occupy, let's say, a node of 16 core instance is scheduled. Out of that, I am taking 3 core for my daemon sets. Remaining 13 core, I will allocate completely to busybox set, so that this will occupy the entire node, and when and this is, as he mentioned, this is a low priority part. So when there is a high priority part that is coming with request of 3 core, this busy box will be evicted and it will request cluster autoscaler to schedule another node. At that time, it will occupy the entire core CPU in the another node, and in the meanwhile, I can schedule 4 more parts in the particular node itself. So this busy box will be running always, and one node will be dedicated for that. Hope that answers you. Yes. Hmm.
These concepts, right, this busy boxing and then putting those kind of backup nodes and all those daemon sets. So, will those be applied automatically, or is it something?
This is a common hosted application only. It is not like we are not hosting separately for each and every customer. Since it is a SaaS application, we host it one place, and with the subscription or licensing, our customers can use our application. So it is not like hosting one for you and one for me, not like that. So it is a common infrastructure. So
So, it is like your application is maintaining across multiple tenants you are doing,
yeah, this is a multi-tenant application, and we serve for all tenants from.
and the solution entirely is owned by you.
Yes.
Regarding the app aware infra part, here, sorry, right side.
Oh, sorry.
We can just implement this for applications with circuit breakers, right? Do we need another service for this?
A circuit breaker you can implement for some connection related stuffs, right? So here we are predicting that something is going to happen, and ensuring we are avoiding that to happen. Circuit breaker comes into picture when something has happened, I'm stopping it.
Okay.
So we are not leading to that part. We already have a circuit breaker also in place, but this is to predict and avoid the issues beforehand itself. So that's where we need awareness.
Prediction is sort of like is there a model predicting it, or is it just
It's
ad
not
hoc based on
It is
extrapolation?
not based on the AI. Actually, right now we have based on all the metrics and monitoring.
Extrapolating basically.
Yes.
Okay.
It's not based on AI. Someone has question here. Yeah. I could not hear you.
For like burst like cases, like when the application has like a sudden burst of traffic, have you had any success like utilizing spot instances?
So we use Spot as well. So, but we can't completely use Spot instance. So we have a 70% of reserved instances, and 20% of on-demand instances, and 10% of Spot instances. So why we chose like that is, we know this is our traffic. For that, we definitely have a reserved instances which we get it in a lower cost. And for a considerable traffic increase, we have a on-demand instances. And if the burst is more than what we have expected, then we will use the Spot instances. Why Spot is coming at the end is, which is unreliable. Since we are using it in the production environment, in case something is happening, we can't switch the pod very frequently, right? So that will have again impact in the performance. So Spot we are using, but with very minimal percentage we are using Spot instances for this particular reason.
So like if let's say there is a lot of availability of spot at the time, you just use as much of it as you can.
Yes,
Okay.
yes. And this is again unpredictable only. So we have configured in our auto scaling group itself to schedule only this percentage for Spot.
I had a question on database scaling that you mentioned, right?
Yeah.
And since you brought up auto scaling group now.
Auto scaling group I mentioned for EC2, but yeah,
Right,
anyways
right.
we can.
So for database, that would be a straightforward solution, right? If you're using a managed database solution, then
Yeah.
ASD would help you handle the
Yeah, but
variances, right?
yeah, we are using AWS managed database services only, and we have sharding, and we have replication enabled, and inside the database to ensure the scaling we have partition enabled, and we have a couple of proxy itself before database to have to reuse the connections and everything. Even though after that point, all writes will going to happen in the same master only, right? And when I mentioned the example that I talked about in the bottleneck, it is a maintenance activity which does lot of writes. So that's why we need a awareness to the app to reduce the load. So that's when we have to need of this solution.
Okay, got it. Okay,
Thanks.
thank you.
Anything else, folks? Yeah. Thank you so much.